In this video, we'll go over two more famous problems in construction geometry. The first being constructing regular n-gons or polygons with any amount of sides, and the second being squaring the circle. We already know that we can construct triangles and squares using a compass and a straight edge, thus n-gons where n is 3 or 4. But many mathematicians wondered what numbers can or cannot n be. And in the 19th century, Carl Gauss proved exactly that. He said, n must be a multiple of a power of 2 and Fermat number. So we know power of 2 can be written as 2k, where k is an integer, and Fermat numbers are written as p equals 2 to the 2n plus 1. And a little side note, Fermat thought any number of this form was prime. He wasn't correct. There are numbers that aren't primes. But for this, n has to be a product of a power of 2 and a Fermat prime. The first few Fermat primes are 3, 5, 17, and 257. And power of 2's would be 2, 4, 8, 16, 32. So he proved that you can construct a polygon with any of these number of sides or any product. So you can do 2 times 3 and have a n-gon with 6 sides, or 10, or 20, so on and so forth. It's interesting to note that Carl Gauss actually constructed a 17-gon, and that later, once he died, it was engraved on his tombstone. He's so proud of it. So right now I'll show you how to construct an octagon, which is one of the n-gons constructible. So if we have perpendicular lines and a circle around them, all we have to do is basically bisect each quadrant of our coordinate axis, and thus we'll have 8 points on this circle that are equidistant. So I'll do that now. So basically, we can construct these 4 intersections by having our compass, the marker starting at the origin, our pivot point being at the intersection of the line and the circle. And then with our straight edge, we can extend out these lines. Let's do that. equally distanced points on the circle. And all we would have to do is connect the dots. And we have an octagon, a regular octagon with 8 sides. Now let us examine our second problem, squaring the circle. The question here is, with a compass and straight edge, can we construct a square given a circle with a specific area? For example, we can take the unit circle, which has area equal to pi. That is, area equals pi r squared, where r is 1. And can we make a square that has the same area? We know the area formula for a square equals as squared. Thus, each side of the square would have to measure the square root of pi. Now, you may think this could be a constructible number, because what we know, it is of degree 2, which is a power of 2. You may want to say, yes, you could do this. But the square root of pi is a transcendental number, which means it's a real number, but it is not a solution to a single variable polynomial with integers for the coefficients. And as it turns out, we cannot construct transcendental numbers. Thus, we cannot square the given area of a circle.